In this talk, I'm going to discuss knowledge graphs, and in particular, focus on the theory that underpins them, the challenges that need to be overcome in order to realize practical knowledge graph systems, and the kinds of applications where knowledge graphs are proving to be particularly effective. I want to start out with a bit of background and motivation. In particular, we might ask ourselves why we would use a graph to represent knowledge in the first place. Well, the idea of representing knowledge as a graph seems quite natural and intuitive and has a very long history. I could mention, for example, the famous tree of porphyry, which is a graphical representation of Aristotle's categories. In more recent times, semantic networks were developed in the early days of AI. And even more recently, if we consider the web, we can think of it as a graph that connects documents via URLs. The idea to transform this into something closer to a semantic network motivated semantic web research and the development of standards for graph-structured knowledge representation on the web, in particular RDF, OWL, and Sparkle. Finally, bringing ourselves right up to date, Google have famously developed and increasingly rely on their knowledge graph. And knowledge graphs are increasingly pervasive, not only in personal assistance, e-commerce and the like, but also in many industry applications. Next, I'm going to introduce a small running example and use it to take a more detailed look at the structure of knowledge graphs, just to make sure we're all on the same page. A knowledge graph consists of a set of entities and values which make up the vertices of the graph, and these are connected by labeled edges that capture relationships between pairs of entities or between entities and values. In RDF, a single such edge is called a triple, with the source entity being the subject of the triple, the edge label being the predicate, and the target entity or value being the object. It's also interesting to note that we could store this information in a roughly equivalent way in a relational database, for example, using tables like these. However, the graph form has significant advantages. In the first place, the graph is more intuitive. The knowledge isn't split across multiple tables, and we don't need to understand hidden details of the database schema, such as foreign keys, in order to understand the structure of the data and to navigate